Oloyede Godliness. I'll be taking mathematics this evening, and the topic we are considering is indices. So I'll start the presentation. So I was told we are preparing for WAEC. I wish us all God's best and success in Jesus' name. So to the class. So the topic we'll be considering this evening is indices. Can you hear me? Hello, students. Can you hear me?
Yes, we can hear you. I don't know why they are not answering. Zeno. Please, why can't you answer the teacher? Please continue, ma.
Okay, you can hear me and you can see the board.
Yes, ma'am.
Can you see the board?
Yes,
The topic we're considering this evening is indices. Indices. When we talk of indices, I don't know, I would like it to be an interaction. So I don't know if anyone can tell me. I know for students preparing for WAEC, you must have heard the word indices before. So can anyone tell me what he or she knows about indices? What you can remember about indices? Hello?
ma'am.
So can you tell me what you know about indices? When you hear the word indices in mathematics, what comes to mind?
I don't know what this is. That's the
You said? You said? You can't remember. Okay.
No, about indices is that I don't know. Yeah, like it has its own.
All right, let's continue. So when you talk of indices, we got the word indices from the word index. So when you talk of index tells us, how many times a base can multiply itself. How many times a base has been multiplied by itself. In this index tells us how many times a base has been multiplied by itself. And when you talk of indices, we have a general notation, a general symbol for indices, a general representation. You can say symbol or notation or representation, which is x raised to power m. I hope you are following me. Are you following me? Hello?
Yes, ma'am. Yes, ma'am. We're following.
Okay. You are the only one answering. Think there are, okay, just one other person. So when you talk of x raised to power m is our power or index or exponent, while x is the base. Do you understand that? You understand that? Hello? Hello? Okay, so when we said index tells us how many times the base has been multiplied by itself, that, for instance, if we have 3 raised to power 5, this is the index, this is the base. So if we say index tells us how many times a base has been multiplied, that means this power of 5 tells us how many times 3 have been multiplied. So when you say 3 raised to power 5, that means 3 in 5 places. How many times? That is 3 in 5 places. 3 times 3 times 3 times 3 times 3. This is what an index means. Now we move to the laws of indices. When we talk of indices, there are basic laws guiding indices. And we have 8 rules, 8 laws. Can you hear me? Hello, Zainab. Okay. Jennifer. Hello.
I think the students, maybe they were disconnected by network or so. They will still join us soon.
So should I wait or continue?
No, you can continue.
Okay. The laws of indices. The first law of indices we have is the multiplication law. So the first law is the multiplication law, where you have x raised to power m times x raised to power n. This is called the multiplication law. Or the multiplication rule. In this case, when you have multiplication, and one thing to note is you can only perform operations on indices. For instance, you can multiply, divide only when the bases are similar. Looking at this first law now, you can see that the base, which is x, are the same. If the base is not the same, you cannot perform any operation on them. So when we have x raised to power m times x raised to power n, the multiplication law. Multiplication law states that the multiplication sign changes to addition for the index. So you have x raised to power m plus n. You add up the index. Then the second law is the division law, where you have x raised to power m divided by x raised to power n. The division law. In this case, division turns to minus. Division turns to minus. So we have x raised to power m minus n. So in as much as the base is similar, that is why we are picking just one base. And the third law, which is the power law. This states when you have this bracket in mathematics generally. Is any student here yet? Okay.
Yes.
Can you hear me, Zainab?
Yes, ma'am.
You understand what I'm writing?
Yes.
Do you understand? Hello?
Yes, ma'am.
So the third law, which is okay. The third law, which is x raised to power a into brackets b. Brackets in mathematics means what? Can you tell me what bracket means in mathematics? I'm asking a question. What does bracket means in mathematics?
Of yes.
Multiplication.
Huh?
I know somebody have already answered.
Okay, someone answered it. What did the person say?
Multiplication.
Thank you. Multiplication. Bracket in mathematics means multiplication. Now, this rule is different from the multiplication law. In this case, when you talk of the multiplication law, you are multiplying the and the power. But in this case, you can see that we have only an index or power. So when you have something like this, you are multiplying the power. So it is called the power law. So this gives you FAB. Do you understand?
Yes, ma'am.
The fourth rule, which is the zero law. In indices, we are told or we are taught that anything raised to power zero is what? Anything raised to power zero is what?
1.
1. Thank you. So this is the zero law. X raised to power 0 equals to 1. This whole word raised to power 0 is equal to 1 as long as it has 0 as its power or its index or its exponent. The answer is 1. Do you understand? Do you understand? Okay, have you written this? Can I clean the board? I want to clean the board. Hello? Hello, can you hear me? Hello? Okay. Can I clean the board?
Wait.
Yes, ma'am.
Okay. Please be fast with writing. Our time is running out.
I've already screenshot it with your phone. That I'll comment it.
Can I clean the board? When you are done, please let me know. Can I clean the board?
Can you people just try to respond to the teacher whenever she asks a question? she has been talking to herself since, and you people are not saying anything. And she was asking you guys questions. Please. You can continue with the class. If they don't get it, they will watch the video later.
Okay. Sorry about that. So we move to the fifth law. This fifth law, we have x raised to the power minus a. It is called the negative indices. Negative indices, that is, we have negative power, minus. Minus means negative. So this law is the negative indices, where you have a negative power. This means 1 over x raised to power a. You can also call it the reciprocal law, because anything minus in indices, it is the reciprocal of the positive indices. For instance, we have 1 over x raised to power a. X raised to power a is the reciprocal of x raised to power minus a. X raised to power a is the reciprocal of x raised to power minus a. So it gives us 1 over x raised to power a. So if, for example, we 5 raised to over 5 raised to power 2, which is 1 over 25. To give you answer in decimal form. We understand that.
Yes, ma'am.
Then the 6 raised to power 1 over a. This is called fractional indices. Now there are 2 sides to the fractional indices. Here you have x raised to power b. Now, 1 here is your numerator, while a is our denominator. Whenever you have any indices of this form, the numerator belongs to, it's just like say you have x raised to power 1 divided by e. So from here, we can see that the numerator goes along with the base. So this rule gives us this. It is called a root, fractional. Whenever you have fraction, the denominator goes with the root. It could be a cube root, it could be a square root, or more, depending on whatever your denominator is. So the denominator always goes with the square root. You have a, and then you have x raised to power 1 inside your root. And x raised to power 1 is the same thing as x. So you have this. The seventh law is also similar to fractional indices, given you have x raised to power a over b. Who can tell me how this will be written based on what we were told in law 6? Who can tell me how that will be written? Can you hear me?
Yes, ma'am. It will be written as b raised to the power of x, b root,
B
and
root,
then
okay.
x raised to the power of a.
Thank you. Thank you very much. So this is this rule. And then when we have a fractional indices combined with, what's it called, a negative indices. Look at this place. We have x raised to power minus a over b. Now, the minus is for the a, of course, but then we know that the b is attached to this. Am I right? So we have something like, now a is a negative power. You know, in mathematics, we talk of board math, bracket of division, multiplication, and subtraction. What that rule is trying to tell us is taking an equation a step at a time. Now, if we want to take this equation a step at a time, we have x raised to power minus a. Let's deal with that first. Using the negative indices, this will give us 1 over x raised to power a, right? Do you understand that?
Yes, ma'am. Yes, ma'am.
Now, let's now come to the divided by b. This divided by b also belongs to this. So this gives us b root, right? So we have rule 8 as, which is x raised to power negative a over b, gives us 1 over b root x raised to power a. Do you understand this?
Yes, ma'am.
So now we'll go to examples based on each law. Can I clean the board?
Yes, ma'am.
I can clean the board.
Yes.
Everybody. Okay. Yeah, thank you. The second law, which is the division law, if we are given 10 raised to power 5 divided by 10 raised to power 2, it gives us 10 raised to power 5 minus 2, which is 10 raised to the power of 3. Do you understand that?
Yes, ma'am.
Now, the third law, when you are given the power rule, when we have another index outside the one inside the bracket, beside the bracket means multiplication. This gives us 2 raised to power 3 times 2. Now, this is different from rule number 1, like I said earlier. Don't make the mistake of adding this up. You are multiplying. Do you understand?
Yes, ma'am.
In this case, you are multiplying. So this gives us 2 raised to power 6. The fourth said the 0 law, anything to power 0. So we are given 1000 raised to the power of 0. Our answer is what?
1.
1. Thank you. Now this fifth law, the negative indices. If we have 5 raised to power negative 3, 5 raised to the power minus 3. This gives us 1 over 5 raised to the power 3. Am I right?
Yes, ma'am.
So which is 1 over 5 times 5 times 5. And this will give us 1 over 125. The sixth law as the fractional. If we have 8 over 27 raised to the power of 2 over 3. This is a fractional indices now. This gives us cube roots, right? We have
Yes.
a cube root here because the denominator is 3. So we have cube root of 8 over 27 raised to power 2. Now, if we are to solve this, equation, when you want to deal with a question like this, for the fact that we have fraction also as our base now is also a fraction. I don't know if you have whole number, for instance, if we have 5 here, that's a cube root of 5 raised to power 2. That will be cube root of 25. But in this case, we have a fraction. How do we deal with fraction when we have our base as a fraction? You have to break down your numerator, 8 and 27. Break them down into base and power, base and index. That is, represent them in the indices form, the indices representation. Now, let me try to explain here. We have 8 over 27. We have to break down 8. We have to break down 27 into base and power in order to solve this question, because we cannot just leave the answer like this. So now, to solve numbers, times 8, but 4 times 2 will not help us represent it in an indices form. So representing 8 in indices format gives us 2 times 2 times 2. When you break you 8, breaking down 27 also, 9 times 3 will not give us a base and an index, or 27 times 1. So if we have 9 times 3, we can break down 9 into 3 times 3 also. This gives us 3 times 3 times 3. Do you understand what I've just explained?
Yes, ma'am.
Okay. So when we write this out, this is still in index format. When we write 8 over 27 out in base and index format, this gives us 2 in 3 places, right? That's 2 raised to power 3.
You have less than 10 minutes now.
3. Wow. So now let's come back to, so we can say, since this power is the same, when you have a similar power, just the way when we have similar base, we pick just one. So also when we have similar power, we can pick just one. This gives us 2 over 3 raised to power 3, since the index or the power are the same. So we come to this, we have square root of cube root, of 2 raised to power 3 over 3 raised to power 3 squared, which is, can I clean the board?
Wait, ma'am. I'm not done.
Okay. This gives us of 2 over 3 raised to power 3 square.
I'm done.
You are done. Okay. Now, when we have cube root of 2 over 3 raised to power 3 raised to power 2. Now, since this is raised to the power of 3, and we have a cube root of 3, don't forget that this cube root of 3 started as a power. This power of 3 will cancel this cube root of 3. Do you understand what I've just done?
Yes, ma'am.
This power of 3 cancels this cube root of 3. So what we have left is 2 over 3 raised to the power of 2. Do you get it?
Yes, ma'am.
So our answer is 4 over 9. We have 10 minutes to go. I don't know. The time might not be enough for the last exam. So we'll stop here for today while I give us assignment towards our next class. We meet next Sunday. Please let's try to come early next Sunday. So this is our assignment for today. We continue next.
You're welcome, ma'am. Have
Thank
a
you.
nice day.
And you too. Are you done writing?
Yes, ma'am.